Alrighty, hello everybody, and welcome back. This is the second meeting of the club this semester. How's everyone doing? Good, bad, neutral? I see a lot of thumbs up. That's good to hear. I guess we can start off with the activities fair. We had the activities fair last week. It was virtual. We had one person show up, which, if I remember rightly, is one more than last semester. So I see this as an absolute win. Again, I'm really not happy with how the Office of Student Engagement handled the activities fair as a whole. Hopefully, next semester we'll be able to get back to an in-person format so we can talk to prospective students face to face. But regardless, it was still fun, so I'm glad we were able to do that. Kind of on the same page here. If you haven't already, be sure to go on to Purple Post and follow the Severe Weather Club on Purple Post. There are a couple of features that I still need to learn about, but if I ever get around to learning those, I can post things like announcements and stuff there. So if you want to be notified about that, be sure to follow us there. I think I wanted to start off this meeting with a little bit of a discussion about local weather and weather happening, around the country. So Anthony, do you want to start talking about that?
Yeah, sure. So we've actually got a pretty active weather pattern coming in tomorrow. And then it'll switch over to after the cold front comes through. It'll be a cold one. So I'm gonna present a tab here. Let's see. Okay, let's start out with this one. And so this is the Weather Prediction Center. Basically, for what we're doing here, we're looking at fronts coming through, and this gives a good prediction of where they're going to be and what they're going to do. So I start out with this, and then as we see tomorrow, there's currently a low pressure system situated basically in northern Nebraska that's going to move this way. And what this does, it actually shows us what's going to happen. And so as this moves along, we can see here that tomorrow at 6 a.m., this is where it's going to be. It should be raining. And then by noon, we're going to see the front fully move through. And then after that is where we'll probably have our chance for snow. We might have our chance for snow between 12 and 12 tomorrow, but this is just the precursor to what's going to come. And then later this weekend, we have a little bit of a not really high pressure, but kind of high pressure coming in Sunday into Monday. Well, obviously it is high pressure. So, and that's going to lead into a lot of things. First thing I do want to point out here is I'm going to pull up the Euro, which is one of our weather models. And this model will tell us about anything you want to know as far as predicting weather. We're going to look at precipitation type and rate for tomorrow. And so, get all these ads out of the way. So I'm going to scroll through here, and this is what the Euro is predicting is going to happen tomorrow. And so the Euro is a little bit better of a model.
Don't get your screen, Anthony.
Oh, you're right. I quit sharing my screen, didn't I? There we go. Thought I hit share. Okay, so here it is. So the Euro here. It's a little bit better model than the models that we have. The European models has more pixels, so it does better in predicting weather on most occasions. Not always, but most of the time. So what we can see here, this front moves through about 6 a.m. is the current time here, and then it goes up to noon here, and then this is 6 p.m. So 6 p.m. it should be out of here. That's good for us. But as we can see here, McDonough County is right here where this little plus sign is. So we're kind of just south of the snow, but we're not that south. That's the Euro model, and I kind of just show a few of the models here. Why did it do that? All right, I'm just going to do my entire screen. Okay, so that's not what I wanted, but the Euro should be, or not the Euro, the GFS will be the same way. A little bit. We're going to move through here. I'm way ahead. Oh, that's why. Wrong model run. Okay, so the Euro will be, not the Euro, I keep saying the Euro. The GFS is about the same way. It has a little bit harder time here, as you can see, kind of figuring out where the rain snow line is going to be. And whatnot. And the other models I was going to show are pretty much the same way. But what I really want to focus in on is what's going to happen Sunday. So Sunday, it's going to get cold, and it's going to get really, really cold. And why is it going to get cold? Well, if we go over here to winter weather and we look at snow depth, we can see that areas to the north of us have a little bit more snow on the ground by a lot, is what the models are saying. And so with this saying, I mean, it's obviously we don't have as much snow. And earlier in the week, we were predicted to get a lot more snow, so this colder air was going to be a lot more intense. But since we're not forecasted to get as much cold or snow, we actually will see a little bit of a difference in feels like temperature. Feels like temperature is basically the temperature in the atmosphere it feels like when you walk outside. So we're going to scroll through here. It's going to be cold Friday, and then Saturday, of course, but then Sunday, here comes the real cold. Sunday morning. This here is Sunday at midnight, and this is Sunday at 6 a.m. So Macomb has a feels like temperature of 7 below, and 6 below is what the Euro is saying currently for our area, and we go through, and it pretty much will hang below zero for feels like for a day or two, actually for a little bit longer of a period. It looks like even as we go further out, which this is into next Wednesday, which don't worry too much about that because it's next Wednesday. And then I'll show the GFS for this as well. But as you can see, I'll even point this out more on the GFS, where the cold air is going to be situated. It's where all that fresh snowpack is, or where there's going to be snow on the ground. So if you remember, here we go into Saturday, into Sunday here. Most of this fresh snowpack was actually in eastern Minnesota, down into Iowa, right through here up into Wisconsin. So this fresh snowpack allows for colder air to happen because of all of the incoming solar radiation or incoming solar energy gets reflected back outward. And so the surface will not heat up. It's actually colder at the surface with snow on the ground. And so what happened earlier this week, most models were predicting that Macomb was going to get a decent amount of snow, anywhere from 2 to 4 inches. And that's not happening now. That's actually shifted more north. And because of that, we will not see as cold of temperatures, 15 below, according to the GFS, is what it's going to feel like. Sunday, and when I might even reach 20 below, it feels like on Sunday. But yeah, basically that fresh snow up north is what's causing all of the coldness. And there's other variants in that as well. But the main thing right now is that snowpack. I'm not going to go a lot into detail, but there is possibility for northwestern Illinois, southeastern Iowa, southwestern Wisconsin to be in blizzard conditions tomorrow. Blizzard conditions are 35-mile-an-hour winds with visibility less than quarter of a mile for 3 straight hours. They're going to get some pretty good winds up there. Gusts probably to 35, 40. Sustained, I'm not sure about sustained. It'll be really close. So those areas up north will probably have some blizzard conditions. They're not under blizzard watch or warnings yet, but wouldn't be surprised if they might get thrown out there. And yeah, that's really all I have. I could go into more detail, but I'll kind of cut it short there and whatnot. So if you guys have any questions about this at all? No? Okay. All right. So I'll throw it back over to Ian.
Cool. Thanks, Anthony. So next, I'm going to be presenting something. Let me get my screen presentation ready. Let's see. Share my whole screen here. Let me know if you guys can see my screen. All right. So this evening, I wanted to give a presentation on the March 2006 tornado outbreak, or I guess I should call it the severe weather outbreak. As we'll see, there's a lot more to severe weather outbreaks than just tornadoes. This was actually a presentation that I made for my synoptic meteorology course. During that course, you have to do a case study where you analyze a severe weather system or any sort of weather system and kind of try to diagnose the causes at a synoptic scale. This presentation won't go too far in depth in that. Unfortunately, I wasn't able to complete that case study due to the COVID shortened semester, but I'd like to get back to that at some point. Well, we'll start with an overview of this outbreak. This was an extended outbreak of severe weather across the central United States. If you lived in central Illinois in 2006, you probably remember this event, or at least part of it. It lasted over 5 days between March 9th and March 13th of 2006. And over the course of this event, this region saw 99 confirmed tornadoes, a derecho event, widespread hail reports, microburst winds, and other forms of severe weather. The things that make this outbreak notable is not only its duration, 5 straight days of pretty intense severe weather, but also its timing. It's not unheard of to have severe weather in March. I know severe weather season is defined, at least around here, as March through the end of spring, but it's really remarkable how how frequent these severe weather outbreaks occurred, on back-to-back days, and also being in between 2 winter weather events makes this event really notable. Additionally, I'll get to this later, but there is another reason why this event is historic. We'll get to that later in the presentation. Here's a little map I made that just kind of shows all the states that were affected by this outbreak. All the states in yellow saw severe weather as a result of this outbreak, and all the states in red were the ones that had tornadoes. This is just a kind of an idea to visualize the extent of this impact, but yeah, it impacted dozens of states. And so we'll begin on March 9th of 2006. On March 9th, this region saw a large squall line sweep through the lower Mississippi Valley. There were 4 tornadoes that were associated with this system, including an F2 in Arkansas. F2s are considered the cutoff for major storms or major tornadoes because those are the ones that are really able to impact structures and therefore pose the largest or start to cause a large risk of life loss. The day was not notable for its tornadoes, though. It was actually more notable for the derecho event associated with it. If you don't know, the derecho, a derecho is defined by the SPC as a large, widespread, long-lived windstorm. And specifically, it is a windstorm that spans at least 250 miles with sustained wind speeds of 58 miles per hour or more and periodic gusts of 75 miles an hour. Derechos are associated with squall lines, which themselves are associated with very strong straight line winds. These things can be very dangerous, and their damage paths can be very extensive. In fact, in this particular instance, the damage path of the derecho was much more extensive than any of the day's tornadoes. Tens of thousands lost power across the American South, and additionally, at least 2 deaths and dozens of injuries have resulted as a result of this derecho. Here are the SPC storm reports for that day, and this is very typical of a derecho day. By the way, I didn't mention this at the start. If you have any questions, feel free to interrupt me. I can't see you on my screen, so if you have any questions, just let me know. But anyway, yeah, as you can see, the storm reports are defined by large swaths of wind reports, not necessarily too many hail and tornado reports, but certainly wind reports that stretch across multiple states. We can also look at the surface here. What we see up here is a very weak low pressure system with a cold front that drapes down here. This cold front is associated with some non-severe storms throughout that day. We also have this stronger low pressure down here that was associated with the shortwave trough. This trough is actually going to come up and reach this low pressure and strengthen it as it heads northeast. But it's this cold front right here that's associated with the squall line that day. So I've actually got pulled up here is archived radar footage of this squall line. If we scroll back here. So here is the sort of storms, precipitation and storms associated with that weaker cold front up north. But as we advance, you can see right here, this is where that stronger cold front associated with that short wave comes through. This is the one that's associated with that squall line. And so if we advance this here, you can see it reach through the area. I want to point out a couple features of the squall line. First of all, you can see right here, this little bulging out of the central axis here, the squall line. That is what's called a bow echo. A bow echo is basically an area of really large, really fast winds that bulge out literally from the squall line central axis. From what I understand, they're caused by turbulent eddies along the structure of the cold front, literally billowing down and forging ahead of the cold front. That causes the storms, that causes the air beyond the cold front to lift up and create even more storms. And that's why you see that bulge there. These bow echoes are associated with very strong winds, and so as you sort of see this squall line develop, you can sort of see where these places are bowing out. Those are the places with the strongest winds, and that's why derechos are so deadly. Go back to our presentation here. This is an example of the kinds of damage that you can expect from derechos. These images are not from that 2006 derecho. I couldn't find images of them, but I was able to find images of a more recent derecho. These are all from the 2020 derecho that struck Iowa last year. As you can see, derechos can get strong enough to level grain bins and grain silos. They're able to push weak structured buildings completely off their foundations. And of course, they're able to entirely level crop fields. Derechos are able to reach wind speeds that rival tornado wind speeds. The difference, of course, is that tornadoes only have a damage path about 1/8 of a mile wide, whereas derechos can span like 1/3 of the country. So yeah, these things can be very deadly, very dangerous. Next, we'll move on to March 10th, the outbreak. March 10th was actually kind of a lull in the severe weather here. It was the day with the weakest or the lowest amount of severe weather. I have here in this slide, it's slightly strange and like something to explore is why there was no weather. The reason is obvious. The system had just gone through, and so it used up all the energy and all the moisture. But the thing that you really want to look out for is how, even despite the fact that all these systems were going through in early March, we were able to sustain so many severe weather days. And so we can look at the surface storm reports here on the 10th. And as you can see, there's not really much, although there is still some scattered hail reports. It is kind of remarkable that even despite the fact that a large squall line had just gone through the region, there was still enough energy around and it's not enough moisture around to cause at least some level of limited severe storms. And so it's really remarkable that even with these little patches here and there, we're able to call this a 5 straight day severe weather outbreak. And now we can move on to March 11th. This day saw a large ramp up of severe weather. This system produced 11 tornadoes on the 11th, 3 of which were F2 or above. The most dangerous of which was an F3 in Perry County, Missouri, that trekked 54 miles. It leveled a trailer park and dozens of other homes and caused at least 2 confirmed deaths. Other storms caused substantial damages to other communities, homes, businesses, and natural forests, which caused large economic damages as a result. Look at the surface analysis here. You can see this low pressure system up here. This cold front is associated with some of the severe weather activity. Also, this dry line right here probably also fired some supercells that went on to hit those rural counties in Missouri. Missouri was one of the states that got damaged the worst by this outbreak. And here are the storm reports, as you can see, in stark contrast to the 9th, which saw mostly wind reports along the south. This one has a much more varied mix of hail reports, tornado reports, and wind reports. And so that's a pretty cool difference you can see there. But yeah, you can clearly see the ramp up in severe weather. This day was a precursor to the worst day of the outbreak. Finally, we'll move on to, or I guess not finally, but we're going to move on to March 12th now. This is the day that everyone remembers. And if you lived in central Illinois, this is probably also the day that you remember. March 12th was the peak of this outbreak. This day saw 62 confirmed tornadoes, 24 of which were F2 or higher. Some notable population centers that were hit with tornadoes. Springfield, Illinois, which is my hometown, had 2 tornadoes track directly through it. They were both F2s. Damaged many structures and caused citywide power loss. I was out of school for 2 weeks as a result of these tornadoes. Other notable population centers that were hit include Monroe City, Missouri, which got hit with an F4, which was the strongest tornado of this outbreak. Verona, Missouri, which got hit with an F2, and also Springfield, Missouri, which got hit by another F2. Those cities also saw some pretty bad weather. There was also other dangerous weather associated with the system. For the cities that weren't getting hit by tornadoes, some places in Kansas were seeing softball-sized hail, which is just a testament to how strong those supercells were to keep that hail in the air for so long for it to grow to the size of a softball. Additionally, microburst winds in excess of 90 miles an hour were recorded in a number of places, including the Quad Cities area and in Kansas City. Unfortunately, 9 deaths and hundreds of injuries resulted as a result of the storms in the system. And additionally, this is the other thing that I was talking about that makes this outbreak historic. This outbreak produced the longest tracked supercell ever recorded. It's nicknamed the six-state supercell because it tracked over 6 states over the course of 18 hours and around 790 miles. Here are the storm reports here. This is pretty much a worst case scenario you can imagine for a severe weather day. And again, for it to happen in such early March is truly remarkable, especially it being its 4th straight day of severe weather in a row. Next, before I get into anything else regarding the storms on that day, I just kind of want to show you this longest lived supercell in its entirety. We're going to see this radar loop. It's about a minute long. It was produced by Iowa State. They show its birth in northern Oklahoma to its death in Michigan. So to keep track of this southernmost cell right here, or maybe it's this one right here. No, it's this one right here. That one is the longest lived one. Got its origins in north central Oklahoma, and by the time it reached the Kansas-Missouri border, it was supercell status. Once it crosses into Missouri, it starts dropping tornadoes left and right. It is responsible for the Springfield, Missouri tornadoes. We'll see in a couple of seconds that it's going to drop that F4 in Monroe City, Missouri. Right now it's transitioning into Illinois. And in a couple of seconds, we'll see that it tracks over Springfield, where it drops both of its tornadoes. It'll keep traveling northeast, and it'll remain tornadic for the remainder of its duration in Illinois. Once it crosses into Indiana, it'll no longer be tornadic, but it'll still be producing very strong winds and hail reports as well. And you'll see it eventually get integrated with the squall line behind it as it reaches southwestern Michigan. So in all, this supercell tracked over 6 states and 790 miles across a total of 18 hours. That is an insane distance, even for a supercell. And so one of the things that I wanted to look at for this case study was what kind of environment is there that is allowing a supercell to track for that long. Hopefully I'll be able to explore that later. And we don't want to watch it again. Okay. Having kind of analyzed what exactly is going on here, you may be quick to assume that all these tornadoes happen right in a row. Let me go back here so I can show you exactly what I mean with that. So if you see these storm reports here, you might think that, oh, well, these happened chronologically west to east as the system moved along here. But oftentimes it's actually not the case. In many cases, there are multiple mechanisms that are driving storm formation. And so the key to understanding this mess of storm reports is to look at when each mechanism is dominating storm production, so you can get a better idea of how the storms are distributed throughout the day. And so as it turns out, let's get here. It turns out there were actually 4 primary rounds of storms associated with the system. If we look at the surface analysis here, this is 18Z on the 12th. You can see the mid-latitude cyclone here. It's cold front back here, and of course this warm front that's draped over the entire Midwest. This was bringing precipitation and non-severe storms like the entire day. But something you also notice right here is this dry line right here. This dry line is well ahead of this cold front. As we know, dry lines are the result of dry air being brushed up against warm, moist air beyond it. Since the dry air is more dense, the moist air will be able to rise over this front and trigger storms. Something you'll see is that this cold front is so far behind that it actually is not the primary driver of the weather for most of the duration of March 12th's severe weather. Most of the storms, especially the severe ones, were actually driven by this dry line. And so the first round of storms was fired around 10Z off this dry line, and they traveled northeast and battered Kansas City. Next, around 18Z, another round of storms was fired off this dry line, and they headed northeast again. This round of storms, the ones at 18Z, were the ones that spawned the 6-state supercell. If we advance to 0Z on the 13th, you can see that this cold front still has not caught up to the dry line. And so we actually see a third round of supercells being fired off this dry line associated with other tornadoes that hit Missouri. And then finally, as we advance to 3Z on the 13th, The surface analysis doesn't show it very well, but around 3Z is when this cold front finally catches up to this dry line, and that's when we see that the cold front actually takes over as the primary driver of the storms, and so the storms transition from being cellular based to more squall line based. And so actually I want to show you this in the radar. We can see exactly what we just saw there. So here's 10Z. You can see here's the dry line right here. The cold front is still way back here. And so the dry line fires this first round of storms, and they travel, oh, did that one wrong. Let's see. So yeah, around 10Z, these round of storms is fired, and they go on to hit Kansas City up here. As we advance forward here, this is 18Z. The dry line is around here, and the cold front is still way back here, so it's still not interacting with this warm, moist air at all. So this is the second round of supercells that was fired. For reference, this is the 6-state supercell right here. And then as we advance up to 0Z on the 13th, this is with the location of the dry line right here. The cold front is still behind it, and so you can actually start to see the third round of storms being fired off this dry line. We transition to the 13th. Here are those supercells being fired. And if we advance right around 3Z, we can finally start to see that this cold front overtakes the dry line. And so that's when it starts becoming more squall-like in nature. There is that cold front there. So as you can see, once that cold front takes over, it starts to take the form of a squall line, and that's how the outbreak ends for the 12th. Back to my presentation here. Just to give you an idea of the kind of environment that these supercells were being lifted into, here's a sounding taking at, I think this is Norman at 12Z on the 12th. I won't go too in-depth into this, but as you can see, we have a very nice surface inversion here. And then here's the parcel line. You can see tons and tons of cape. Additionally, we have winds veering with height. This is pretty much a best case scenario for a severe weather day. And so that's part of the reason why we were able to have a supercell that lasted as long as it did. Next, I kind of want to talk about the Springfield tornadoes. The first one entered Springfield around 8:20 p.m., entered on the southeast side of town, near Constitution Drive. If you know where that is, that's where the target is. Here's Veterans Parkway. It tracked east through across Veterans into Wabash Avenue. It kept going and then dissipated sometime south of downtown, thankfully. Something I wish this diagram showed you was that this tornado was actually on the ground for over an hour before it reached Springfield. It actually first touched down in Pike County, 66 miles southeast of here, and then tracked all the way to Springfield. So that was actually the longest tracked tornado of this outbreak. Just for reference of why this outbreak is so important to me, here's the tornado path. This is my house right here, and this is my grandma's house right here. She had a tree put through her living room as a result of this tornado. The other tornado that hit Springfield, it appeared right as the other one was dissipating. It started on the east side of town and traveled northeast across Dirksen Parkway here before dissipating after it crossed I-55, obviously causing a lot of damages to the houses and businesses along here. Actually, this area of town is mostly just poor housing, so there was a lot of economic impact associated with this tornado in particular. Here's some pictures of the Springfield tornado. This picture was taken on Veterans Parkway. Back there is Constitution Drive, where the tornado entered the city. Here's the target, and as you can see, very massive damage to the hotel here. Here's a picture taken on Wabash Avenue. Here's a now defunct business. And here is a billboard that got completely knocked over as a result of the winds. And then probably the most iconic picture for at least Springfield residents of this entire outbreak. This right here is the Lauterbach man. If you live in Springfield, you know him. He stands outside the Lauterbach Tire Company. It's a locally owned just tire shop. He's about a 15-foot tall statue of a muffler man holding the American flag. This was a picture of him taken on the 13th. His head is gone. It was later found over 2 miles away in someone's backyard. Finally, we can talk about March 13th. March 13th saw a decline in severe weather to kind of round out the outbreak. This isn't to say there wasn't a lot of severe weather, though. 15 total tornadoes touched down, all in a line in northern Mississippi and Alabama. They were all F1 or weaker, so thankfully there was minimal damage. No fatalities as a result of the weather of this day. Something that I wanted to look at, though, as part of this case study is what caused these tornadoes to form in quick succession. I'll show you what I'm talking about here. Here's this line of tornadoes right here. I was originally thinking that it could be an example of a cyclic supercell. What those are basically supercells that kind of have weak support, and so what they'll do is they'll undergo rapid intensification and weakening periods. Whenever they intensify, they'll drop down a new sort of weak tornado that spins around for a few minutes before going back up. They'll weaken, and then it'll intensify again and drop another tornado. So I was thinking maybe that could be the cause of this sort of line of storms here, or this line of tornadoes. Unfortunately, I was looking around the articles posted by NWS Birmingham and NWS Huntsville, and I couldn't find any mention of cyclic supercells. Maybe they were just too distracted by the derecho that had come through, 4 days prior. But I was hoping to find some mention of that. That's something I would like to look at some point. But as you can see, finally, there's a wind down of severe weather. This is the last severe weather day of this outbreak. So to kind of summarize all the impacts here, obviously 5 straight days of severe weather. There were a total of 10 deaths as a result of the weather of this day, as well as hundreds of injuries. Also, Wikipedia estimates that there were approximately, or probably in excess of $1 billion in damage throughout the entire Midwest as a result of property loss, lives lost, resources lost, crops lost. There was a lot of damage as a result of these storms. Another thing to keep in mind here is that all of these damages were compounded by the fact that a winter storm came through less than a week later. Obviously, we're still in early March, and so it's still pretty much winter in the United States. A pretty bad blizzard hit much of the Midwest a few days after this, dumped multiple inches of snow into the area, and obviously this severely hindered any damage assessment and rebuilding efforts. All in all, this was just a really bad case scenario for severe weather as a whole. But that is all I have. Thank you for listening. Do you have any questions for me?
I have 3 questions for you.
Sure.
One, on your March 10th day, whenever you said there was only hail, what I would do if I were you, I would look back into that. I know you don't really care too much about March 10th, but I would assume those are all elevated storms. Elevated storms mainly will drop only hail and very little anything else.
Yeah, Dr. Finch mentioned something similar. That's definitely something I was going to look at before the COVID shortened semester.
Yeah, I would almost bet a lot of money that those are all elevated. There probably wouldn't be a lot of surface instability, and so everything would just be, LCLs of the moon, and then you get things like that. What else was I going to say? Oh, instead of cyclic, if I were you, I would look more into tornadogenesis. That seems to be tornadogenesis is basically just, one tornado after another. It undergoes transformations to keep producing. It's like cyclic, but it's a little bit different. But if I were you, I would look more into that. That might answer your question a little bit better. Instead of cyclic, look more into how does tornadogenesis occur. It might not be the correct answer, but I think you might get led more on the right path instead of cyclic there.
I'll be sure to look at that.
And then the last thing I was going to tell you, whenever you're looking at, later on why it squalled out at the end, I would look more into the 0 to 6 kilometer shear vectors, because what ends up happening is whenever these storms come through, the 0 to 6 kilometer shear vectors probably got oriented parallel to the front. And when that happens, the winds no longer will push away rain or anything from the storm. And this will actually occur everything to go linear. Because there's no longer anything saying, okay, you're not gonna rain into this because the 0 to 6 kilometer shear vectors aren't perpendicular. That would throw the rain away. But if they're parallel, they just keep throwing the rain into everything. That's kind of the layman's term of it. But with that, they actually will squall out pretty fast if they actually get parallel. And I would assume on that day, and it typically doesn't happen in the morning or the evening, or in the morning or the afternoon. It'll typically be a late evening thing or nighttime thing that, obviously you get your squall lines. It'll occasionally happen in the day, but I would almost bet that that's probably one of the reasons they've squalled out was that 0 to 6 kilometer shear vector, because once it gets parallel, like I said, it no longer throws the rain away from each storm. It kind of just rains into each storm, and then it just gets into this little line structure, and it just squalls out. That's what I've kind of been learning a little bit about. That might not be your correct answer 100%, but I think that would maybe give you a little reason why into your further research and whatnot.
I'll definitely look at that. I had never actually heard of that before. So yeah, no, I want to look at that for sure. Any other questions, comments, or concerns for me? Cool. Well, thank you for listening, guys. This was pretty fun. Next week, we're probably going to try and have another student presentation. If you have an idea for something you want presented, or if you want to present something, just let me know. But yeah, with that, I guess we can call the meeting there. Thanks, everyone. I'll see you next week.